Hi, everyone. Welcome to my JayDoc Free Health Clinic chatbot final demo. I'm excited to share with you all the progress that I've made over the course of this semester and the final product. So to start off, one of the first things that I want to talk about is my application itself and the structure. I used a Next.js frontend with a Flask backend. And one of the main things that I primarily worked on was creating a Docker Compose file that can create Docker images for both the front end and back end. So we can go ahead and do that to kick off this process. The first thing I'm going to do is Docker Compose build. And essentially, like I mentioned, this is going to create those images for the front end and back end. And we can then use those images to create and build our Docker containers, which is very, very important for creating an environment for the chatbot to be in a localized service, localized container service, excuse me. And what I'm going to do next is Docker Compose up. And this is going to create and build those Docker containers, which are very, very important, like I said, to create that localized container service for the chatbot. We can then copy this link here and paste. And this is the landing page of the chatbot. And this entire application is meant for the underrepresented population of Kansas City to have access to a tool that can allow them to access information about the JayDoc Free Health Clinic and what services are provided and other miscellaneous questions that they may have about their potential visit. So what we can do is these are some of the 5 questions that I've typically used in order to test this. And we can ask a complicated question such as, what are the different specialty nights at JayDoc? And we can enter that query in here and click submit. And so you have this loading bar here, which loading text here, which shows that the query is being processed. And we can go back here. And I created a bunch of debugging lines of code in order to show the user exactly what's happening. So everything from receiving the post request at the query endpoint, all the way to describing what the actual query was, the time it takes to connect to the database, the time it takes to embed, the time it takes to query the database. And here are the relevant chunks that were pulled based on cosine similarity from the MongoDB database. And right now, as you can see here, it's processing the query at hand. And due to the amount of time that it actually takes for this, I'm going to go ahead and pause the demo. And once we get the results, I'll show you all the post requests that we get and the response. Be back in a second. All right, and we're back. So as you can see here, a post request was sent back to the front end with the relevant information. And as you can see here, this is the response to the query that we asked. The different specialty nights in JDoc are yada, yada, yada. It has all the information about all the different nights at JDoc, as well as what the different specialty nights are. So this is a comprehensive way to gain access to information about JDoc. And so this is just a general functionality of the application itself. Now I'm going to go over the GitHub repo. Before that, one thing that I should mention real fast is that suppose you only wanted to access certain elements of this application, you can use the make file here in order to access those elements. So suppose you wanted to only focus on installing the backend and front end, you could use make and then install backend or install front end to do that, as well as any of these other green tags for different elements of the application. Now going into the GitHub repository, I want to reiterate that the purpose of this application is to provide a platform for the underrepresented population of Kansas City, a tool that they can ask questions about JDoc Free Health Clinic, anything from the different services to financial questions regarding paperwork and different policy plans, et cetera, et cetera. So here's the primary architecture of my application. Like I mentioned, it's a Next.js frontend and a Flask backend. So the Next.js frontend will prompt the user to enter a query. A query is then passed to the Flask backend. A gist embedding model then uses that query converts it into an embedding, and that embedding then undergoes cosine similarity search via a MongoDB database. MongoDB is really neat because it has the Atlas vectorized database search, which is what I use for this cosine similarity search. All the relevant chunks plus the query are then compiled together and curated into a prompt. That prompt is then passed to a Mistral Llama file. And this Llama file is not, like I mentioned, within the Docker container or the Docker image. It's separate and it's located locally on my hard drive. And then that output is then passed to the Next.js frontend where it's displayed to the user. And this is just a textual summary of what I just said. It's important that when you begin the application that you utilize the Docker containers, or you utilize the Docker files, the Docker compose, and the make file to access different elements of the application. It's important that you clone the repository to get all relevant files for this project. And you have to ensure that the Docker and Docker compose installations are complete. I know I quickly showed you all the command line of how to actually get the application up and running. But like I mentioned before, that make file is very important to access different elements of the application if you so choose to only focus on a certain element. When accessing the application, you use the 3000 port, and that's what this shows up as. And here's an example for running tests. The tests are located in the test directory, and they use PyTest. And you can use the makefile and the test backend command in order to quickly undergo those tests. Here's another example usage. What services did JayDoc offer? I'll explain one thing that I noticed here in a second about how the query makes a difference as to how long it takes to generate the text. And that's where we come into the performance and evaluation, the speed category. So one of the things that I realize is the more complicated and complex the question is, the longer it's going to take to actually generate the text. And this makes sense. A question like, do I need insurance for my health visit at JayDoc is more like a yes or no question. So it really doesn't need that much text in order to get its point across. But a question like, what are the different specialty nights at JayDoc? Or can you tell me more about the audiology and diabetes nights at JayDoc? Those are going to take a little bit longer because it requires more text to actually get the point across. So really the text generation time is dependent on the type of question that's being asked by the user. And on average, it took about 524 seconds across all 5 of those questions, which realistically is not really good. You probably wouldn't want to use this, like I said, in a deployment setting. You definitely would want a different approach to this problem, potentially not using a llama file, maybe just using a regular API or fine-tuning your own model and using a Hugging Face endpoint or something else along those lines. Number 2, for performance and evaluation, I want to go over accuracy. So for this, what I did was I curated those 5 questions that I showed up here, as well as their corresponding answers. Now, what I wanted to do is compare the answers of GPT and RAG with those fixed correct answers. So I used cosine similarity for this. So I ran the queries through both the RAG system and GPT, got their corresponding answers, and used cosine similarity with the actual answer to see how similar those answers were. And this graph here shows those results. As you can see, RAG outperformed GPT across all 5 questions, albeit only by a little. But I think that little makes sense because the RAG system has access to data through the vectorized database that the GPT model does not have, which makes it a little bit more enhanced than a regular standard GPT model. Last but not least, I wanted to go over the CI/CD pipeline really quick. As you can see, we have a passing badge here. And if you go to the Actions tab here, you can see that each time you push something to this GitHub repo, it triggers the CI/CD pipeline because of the GitHub workflow document here, this docker-image.yaml file, which contains all information regarding GitHub as well as actions, GitHub Actions. And as you can see here, it does a variety of different stuff like installing dependencies, formatting the front end and back end, linting the back end, running tests for the back end, all the way to pushing the backend Docker image as well as the front end Docker image, as per the requirements of the CI/CD pipeline guidelines for our rubric. And that's all. Thank you so much for listening, and I hope you all have a great day.